Welcome to qnawire.
In this question, we have a 3 kg object, and then it is moving at velocity 7 j meters per second, and then there's a force exerted on the object, 12 newtons for 5 seconds. Okay, in part A, we want to calculate the final velocity of the object using the impulse momentum theorem. Okay, so the impulse momentum theorem is F times delta t equals to delta p. Okay, so the force is 12I, delta t is 5 seconds, so this is delta p, and this is equal to 60 I Newton seconds. So the final momentum of the object is pi, initial momentum, plus delta p, and this gives us, so the initial momentum is 3 times 7I. This is the mass, this is the initial velocity, and then the delta p is 60I, so this is 7j, and then we have 60I plus 21j meters kg meters per second. Okay, then the final velocity Vf is just Pf divided by m, so we have 1 over 3 times 60I plus 21j, and this gives us 20I plus 7j meters per second. Okay, so this is the final velocity of the object. Okay, then in part B, we want to find the acceleration from A equals to delta V over delta T. Okay, this is V final minus V initial divided by delta T. So delta T is 5, and then V final is 20I plus 7J. The initial velocity is 7J, and then this gives us 4I meters per second square. Okay, so this is the answer for part B. Then in part C, we want to calculate the acceleration using Newton's second law. So A is the summation of forces divided by mass. This is equal to 12I divided by 3, and this is 4I meters per second square. So this is the answer for part C. In part D, we want to find the object's vector displacement. So we are asked to use this formula. Delta R equals to VI T plus half A T squared. So VI is 7J, T is 5, the acceleration is 4I, and then T squared, 5 squared. Okay, so calculate. This gives us 50I plus 35J meters. Okay, so this is the answer for part D. In part E, we want to find the work done on the object. So we are asked to use this formula, force dot delta R. Okay, the force is 12I dot product with the delta R, which is 50I plus 35J, and we get 600 joules. Okay, the I dot j is 0, so only the I component, only the I dot I term survives. Okay, so this is the answer for part E. Okay, next we do part F. We want to find the final kinetic energy. Okay, so final kinetic energy is half mvf squared is half times m times vf vector dot vf vector. Okay, so the mass is 3. The vf vector is 20i plus 7j. And then you have to dot it with itself. So we get half times 3 times 20 square plus 7 square. And this is 673.5 joules. Okay, so this is the final kinetic energy of the particle. Then in part G, we want to find the final kinetic energy using half mvi squared plus w. Okay, so half mass is 3 kg, vi is 7 meters per second, and then plus the work done is 600. So this gives us 673.5 joules. Okay, so this is the answer for part G. Then in part H, we want to compare the results in parts B and C. So parts B and C have the same answer. And similarly, parts F and G, okay, have the same answer as well. Okay, so that's all for this question.